All right, welcome to this video on finding the volume of composite solids. Today we're going to talk about composite solids as well as adding and subtracting decimals. All right, we started on page 133 where it talks about a composite solid. So if you think composite shapes are flat shapes like squares, rectangles, parallelograms, trapezoids, triangles put together, you have to break them apart, find the area, add them together to get the composite shape. Composite solids is the three-dimensional version of those, all right? So instead of area, we're finding volume. So if we find the volume of this part of the composite shape, this part, and then this part, we would need to add them all together to find the total volume. So that's kind of where we're headed. But before we can do that, we need to know how to add and subtract decimals. And I talked about it in class. If you know how to add money, as you've probably seen before, you know how to add decimals. Because a lot of times we write money, $2.50 as decimals. The $2 are on this side of the decimal point, the cents are on this side. So you line up the decimal point, and then you add the cents, and then the dollars. All right, so as we looked, this is on page 134, you line up the decimals, so it's not like multiplying, where you don't have to worry about the decimals as you multiply. You do have to worry about the decimal, line them up, and then add. And then I added some trailing zeros here. You don't have to do that in addition, but it might be a good idea. All right, and then I give you a chance to try it on your own. All right, so I give you these two problems. Again, adding the trailing decimal, or the trailing zero. 7 plus 0 is 7, 6 plus 5 is 11, so you put a 1 here and then 1 here. 1 plus 1 plus 3 is 5, and then 2 plus 1 is 3. And then don't forget to bring the decimal straight down. This one's a lot like it, except you had to align the decimals when you wrote 4.5 over 2.98. All right, and again, the decimal comes straight down, even in the answer. All right, then we did subtracting decimals. All right, when we do subtracting decimals, it might be a good idea to put those trailing zeros, because otherwise you might be tempted to do this, where you have 2.5 minus 1.98. You think 8 minus nothing is 8. Well, it's not minus nothing. It's actually 0 minus 8, which would not be 8. So the 0 put up there helps us remember, oh yeah, I've got to borrow from the next person over, the next number over, and then rework it. All right, so this was just kind of a refresher on how to subtract decimals and to give you a chance to practice. All right, so put the 0 here. It's 0 minus 7, can't do it, so you need to borrow a 10 from the 8, so it becomes 7, and this 0 becomes a 10. 10 minus 7 is 3, 7 minus 6 is 1, 4 minus 3 is 1, 5 minus 1 is 4. And again, line up the decimals, bring the decimal straight down. All right, same thing on this. All right, line up the decimals, put a trailing 0, and then subtract. All right, then we went back to composite solids, and we looked at this shape. We changed the numbers a little bit so they're a little bit nicer to work with, but this idea is the same. We break this kind of L-shape block of wood, I guess, and you broke it into two recognizable shapes, two boxes. Okay, so we need to find the volume of this top box. So length times width times height, and the length is 14, the width is 7, and it's kind of hard to find the height here. You had to come all the way back over to here. See, this line is 7, so that means this line is 7, this line is 7, this line is 7. So 14 times 7 times 7, 14 times 49, 686 centimeters cubed. Now that isn't our answer. That's just the volume for this part of our shape. Then we had to go back and find the volume of this shape. Well, we found out it's the same block, just put on end. All right, so it's like a kit or some building blocks as a kid. You put two building blocks together to make it out. They're both the same volume, so what do? Double it or add them together. So 686 plus 686 is 1,372 centimeters, and I can't believe it. I should have put a 3 there. All right, I'm going to change that right now as I speak. All right, we're going to pretend that didn't happen. At least I think we're going to. Yeah, there we go. I'm going to put a 3 right there. It's going to be in a different color, but at least on the internet it's going to look right. Okay, now I feel better. I can sleep better at night. Okay, so that is one composite shape. Now, we didn't have time for these in class, but these are on page 139, I believe. And your worksheet references these, so I thought, I probably should work them out. So I went ahead and worked them out before I made the video. the same idea. We want to find the volume of this block of wood. So how do we do that? Length times width times height. The length here is 6, the width is 6, and then the 9 came from down below. See, if it goes from here to here, and that's 9, this has to be 9 as well. All right, so 6 times 6 is 36, times 9 is 324 millimeters cubed. Now I circled it, that doesn't mean I'm done. All right, that's part of my answer. Now here, I have another block. It's going to be bigger. This one is 15 by 9 by 5. So that turns out to be 675 millimeters cubed. Now what do I need to do the volume of this block and the volume of this block? I want them all together, right? So what do I need to do? Find the total, which means I'm going to add, and I get 999 millimeters cubed. All right, this one's a little bit different. You have one like it on your assignment. So if you're watching this video, you are definitely ahead of your classmates. You're getting a little extra help, so good on you. All right? So this box right here is got a hole in it, right? It's kind of got some empty space, a tunnel, if you will. So what we need to do is find the area of this box without that hole in it. So what does that mean? Well, I've got my length, my width, and my height. So my length is 6, width is 10, height is 4. It doesn't really matter what order we put those in. We're going to multiply those three numbers. 6 times 10 times 4, which is 240 centimeters cubed. All right? Now, that would be our answer if this tunnel or this empty space wasn't in here. Okay, but the empty space is there, so we need to find how much volume it is. So the volume of the empty space is length, which is 4, height is 4, and then our width is the length of this width. All right? Because this goes back as far as this. We're assuming it goes all the way from one end to the other. So it's 4 by 4 by 4, which is 64. So now what do? Unlike this one where we added the volumes, we're going to subtract. Because if you think about it, I've got a block of wood. If I cut a hole into it, I am taking away volume from it. All right? I'm subtracting. So I need to take 240 minus 64 and get 176 centimeters cubed. All right? Okay, then I gave you time to work on your assignment. This part looks a lot like adding and subtracting decimals. Okay, I'd recommend doing one at a time, especially on this one. And then here, make sure you line up your decimal. On number 2, the key word here is this is a cube. And what do we know about cubes? All the faces are squares, meaning all sides are equal. All right, so if this is 5 centimeters here, that means this is 5 centimeters and this is 5 centimeters. So what do we have now? We have length, width, and height. All we need in order to find volume. All right, just make sure you're careful on the label. Number 3 looks a lot like the problem we just did. Find the volume of this whole box, and then find the volume of the tunnel or the empty space. All right, and then last but not least, break this piece, maybe here, I don't know. You figure out where you want to break it, and then find the volume of each of those boxes, and then put them together. All right, thank you for watching this video. Hopefully you found it helpful. And until next time, bye.